All right, so here are our open-ended review, all right, questions. So you have this first one here. All right, you have 4 possible kinematic equations to use. You have to figure out which one you need to use. And how do we do that? You got to break down and find all your given pieces of information. All right, so aircraft or a fighter jet catapulted off an aircraft carrier, which is starting from rest and gets up to 120 meters per second. If the aircraft carrier deck is 75 meters long, what is the acceleration? So, all right, anytime you go from rest, all right, starting from rest and getting up to speed, your initial velocity is 0. So first thing you got to do is write that. That will count as a point. All right, gets up to this new speed. That's your final velocity. All right, that's your second point. Aircraft carrier is 100 or 75 meters long, so that is your distance here. What is the acceleration? Your question mark. Now notice you have a total of 5 potential variables for these kinematic equations. All right, your final velocity, your initial velocity, your acceleration, time, and distance or displacement. So the easiest way to figure out which one, which of the equations to use is which of the 5 variables out of A, VI, VF, D, and T don't we have listed. We are looking for A, all right? We have VI, we have VF, we have D. We don't have T anywhere located in the problem, nor do they ask us to solve for it. So we look for the equation without T. That does, this doesn't. And quick double check, does it have everything else? It has VI, it has VF, it has acceleration and distance. So yes, that is the equation that we're going to use. Write it out. Next thing, fill in everybody where they need to go. All right, 120, don't forget the squares, 0 squared plus 2 times A, all right, which is, since we're looking for A, we're going to leave that, and the distance was 75. All right, plug it all into the calculator. All right, 120 squared, 14,400, right, I believe so. Took my calculator, very good. So 120 squared. Yep, 14,400. 0 squared goes away, so we don't even need to worry about it. Now, this is kind of all together. So you have to do 2 times whatever your distance is. 2 times 75. It's going to give us 150, and it's 150A. You cannot subtract this 150. It is multiplied by A. So the only way to get rid of the 150, all right, it's 150 times A, so we're going to divide both sides by 150 to get rid of it. And when you do, A is going to come out and kick out a 96, and the unit for acceleration is meters per second squared. That you will have to memorize, and it must be labeled on your exam. All right, so this will be like 1, 2, 3, 4. Writing this out, 5, 6, 7. All right, for the work, 8, and 9 points for the unit, right? Total. That's how it would be scored. Now, got that. Next, if you miss it, we'll come back. All right. This one is a conservation of energy, all right, problem that you're going to do. Is instead of having the full blown out word problem, you have the equations here. You have your initial height, your initial velocity, your final height, but we are not knowing what our final velocity is. Since the object, all right, is the same object, the mass is not going to really come into play. We can actually cancel out the m's, so we're going to scribble out the m's. Everything else, though, we need 1/2 VI was 12, so you have to do 1/2 VI. Now, it's squared, you must square it, so we're going to write it out like this. Bring down the plus sign. Now, for our class, G, gravity, if you don't remember, we use 10 for that value. Multiply that by, all right, our initial height, HI, which is 36, equals 1/2 VF squared. Now, we're looking for VF. This has got to stay together until the very, very end. And then bring down the next plus sign, G, which is 10, times HF. HF was 6. Okay, now we're just going to kind of plug and chug this into the calculator from here. You must type it in like this. All right, well, you don't have to, but it'd be the easiest way to go about it. 1 divided by 2, parentheses, 12 squared, close it. All right, don't do half of 12 and then square that number, all right? The initial velocity has to be squared. So that's 72. Bring down the plus sign. This comes out to be 360. Bring down the equal sign. 1/2 VF squared. That be chilling. That stays again. Stays the same until the very end. Bring down the plus sign. 10 times 6, 60. Right? Whoops. So we want to get this all squared away here. All right? We want to make sure that 1/2 VF squared is the only thing left on this side. So we're going to simplify over here real quick. Add these two together. We're going to get 432 is equal to 1/2 VF squared plus 60 minus the 60 from both sides. You're going to get 372 equals 1/2 VF squared. Now, from here, again, we want VF by itself. So we have to get rid of this 1/2. How you do that is you have to double both sides first. 372 times 2 is going to give us 744. And that's going to leave us with VF squared. To get VF by itself, to get rid of this squared, you have to square root both sides. So the square root of that will give us our VF. And that will kick out an answer of 27.28, and the unit meters per second squared. Okay, so the points kind of for that, 1, 2 for sure, right? For showing the work and the simplifications here. Okay, 1, boom, 2, 3, 4. All right, our 5, 6, 7. 6 for the correct answer, 7 for the correct unit. Yeah, and if you don't get it, guys, you can always come back right up to this. I'm just trying to get to this as quickly as we can. So next thing, we have a free body diagram that gives us a bunch of different information. Remember that these two equal lines, right, referring that the top and bottom force vectors are equal in magnitude. So they're going to be the same number. All right, all you're given is that the mass is 50 kilograms, acceleration is 3 meters per second squared. You were asked to find FG, FN, FF. So how do we go about it? Well, I gave you the equation here that FG is mass times gravity. So mass times gravity would be the first thing I do. FG, M times G. So I'm doing the mass, it's just 50 times gravity of 10. I'm getting 500 newtons. Any force is measured in newtons. So our FG is 5 hundo. Once you have that, note equal lines here. So those on a flat surface, normal force and gravitational force or weight are the same. Boom. Then we're kind of stuck. All right. So I'm going to do this as simple as I possibly can. You're given the net force equation, so find and calculate the net force. Mass times acceleration. Mass was 50. Acceleration was 3. 50 times 3, 150 newtons. Now, based off the free body diagram, guys, what direction do you think this thing would be? Moving? Right. Right? As you can tell, right? The applied force vector is larger than this force. So, the net force has to be 150 newtons to the right, which means that the right side force is 150 greater than this. So how do we find this? Subtract. So the friction force would be your applied force minus the net force. So 200 minus 150, and we are going to get 50 newtons here. All right. So you need to do this, all right, get this, and draw these boys in. All right, so that'd be like 1, 2, 3. You show the work here as 4. Get the correct answer here as 5. Show this work as 6 to get this final answer here as your 7th point. And then we're going to get into one of our collision type of problems. So one of our collision problems that we have dealt with in momentum. This is an inelastic collision because the two objects stick together afterwards. So how we do that is you do the mass times times its velocity. These things go together. These things go together. This and this get added, and they're multiplied by our final velocity, which we are going to be looking for. So mass of the first is 10. Velocity is 9. Bring down the plus sign. Mass is 12. Velocity is 0. Bring this over. 10 plus 12 times RVF. All right, boom, 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 boom. 90. This goes out, so it's going to be 90 is equal to 22 times VF. All right, so 90 is equal to 22 VF. To get VF by itself, divides both sides by 22. And we're looking at approximately 4.09 meters per second. All right, so it's pretty much 1 point here for writing out this, 2 for this, all right, 3 for kind of doing our little dividing, right, simplifying, do a little divide action, 4 and 5. And then our other type of collision problem is going to be an elastic collision. So this right, total momentum before must equal the total momentum after. So these guys go together. These guys go together. You must add the negative signs if they are there. All right, so all of these are going to wind up going with each other. So we have 5 times 7 plus, all right, M1 is 12 times negative 15 equals 5 times negative 20 plus, all right, 12 is this times V2. So it's going to be 12 V2 prime. All right, but we can do that. All right, so your first point. Second point, start to simplify this. Multiply these out, 35. 12 times negative 15, that should be a negative 180. 5 times negative 20 should be negative 100. Bring down your plus sign. This stays together until the end. You cannot add this 12 to anything. These are connected, all right, until the very last step. All right, if I simplify these things, all right, what do I get? 35 plus negative 180 is going to be negative 145. All right, that equals this right side. Again, we want to get this isolated by itself, this 12V2. So because this is a negative, to get this over to the other side, you got to add it. So add 100 to both sides. So you're going to be left with negative 45 equals 12V2. And then to get the V2 by itself, or V2 prime, the new velocity of the second object after the collision, you're just going to do 12 divided by 12, and then negative 45 divided by 12, right? 12s disappear. So in your calculator, negative 145 divided by 12. And this should kick out an answer here of negative 3.75 meters per second. Okay, so you got to do that. Simplify that stuff. Second point. Break it down to the third line. Cool. All right. Get this dude over. It's your fourth point. Do the divide, fifth, and then 6 and 7. 6, 7. That's right. For the correct answer and unit. All right.